Right, hello everyone. So today I want to go through levels of measurement, which is a very, very crucial topic in order for you to understand how to pick out the right statistical test when you're doing a psychology exam. And I haven't filmed a video for levels of measurement before, even though I've had YouTube for 5 years, just because it was part of statistics. But I think a lot of students generally really struggle with what I mean by levels of measurement. So I'm going to go through this. So essentially, I'm going to keep this quite brief, but essentially, in order to pick the right stats test, you need to be able to pick out the right experimental design. Is it matched pairs? Is it independent groups? Is it repeated measures? I'm not going to go through that now, but you do need to be able to pick that out. You need to be able to pick out what the test is of. Is it a test of a difference? So is it an experiment? You're testing to see the differences in the DVs. Or is it a test of a relationship between two covariables? So those two are relatively simple to pick out. The last one is levels of measurement. And for psychology, you need to be able to pick out one of three different types of data. So what we're talking about here is nominal, ordinal, and interval data. Now, this is a particularly hard part of the spec because there is a bit of judgment needed. There's no right answer necessarily, but you do need to judge whether data is ordinal or interval, and sometimes you can kind of argue either way. So I'm going to start off quite easy, but the basics is this. Essentially, data can be used in multiple different ways: nominally, ordinally, intervally. And let's start with what we mean by nominal data. So nominal data is categorical data. Data where you can put people into categories, and generally speaking, you can only be in one category. So whether you are a smoker, a vapor, or you don't smoke or vape, generally speaking, you can be in. Now you might say, "Well, I'm a smoker and a vapor." Well, that will be its own category: smoker plus vapor. So nominal data is essentially where you put people into categories and you tally how many times that comes up in the data. It is a weak form of measurement. And what I mean by that is it doesn't tell us the strength of which that data is being used. So let me give you a couple of examples about what is nominal data. I've got some just here, for example. So I could get this information from you. I could get all of this information from you. Single, eye colour, type of pets owned, and favourite colour. What I mean, so generally speaking, yes, you might have type of pet owned. You might have several. That's fine. In that case, that's the exception to the rule. You might have a bird. You might have a cat. You might have a dog. But generally speaking, you only have one marital status. You only have one eye colour. You only have one favourite colour. Generally speaking, my favourite colour is purple, for example, because it's the only correct choice. My favourite colour is purple. What nominal data doesn't tell us is how much I love purple. So I really love purple. The DSM-5, that colour there is beautiful. But I might be next to someone who's also put purple, but they didn't really have anything else to decide. I like purple, but it's okay. But yet we've both put purple. So nominal data is quite weak because whilst it tells us how many people like purple or how many people have a dog, it doesn't necessarily tell us the strength of that. So some people might have a dog, but they didn't choose one. They don't particularly like dogs, whereas someone might have a dog and absolutely love it. So a couple of key things you need to know about nominal data is that, like I say, it's categorical and there's no order to things, and that's quite important compared to the other ones. Favorite color, I can't put that in order. I might be able to rank it eventually once I've got all the numbers, but I can't put red above blue, above purple, above orange. That doesn't make any sense. So essentially, you're just collecting categorical data. And generally speaking, each data point can only belong to one category. Nominal is easy. It is the easy one. Students generally have no issue in picking out what is nominal data. Okay? Where it gets harder is ordinal data. So the difference between ordinal data and nominal data is actually quite difficult. So ordinal data is data that can be put in order or it can be ranked in some way. So for example, how funny do you think the in-betweeners is on a scale of 1 to 7? Now I can rank the responses, 1 being not funny at all to 7 being hilarious, and I can rank them. So that is ordinal data. And any time you're asked to collect a Likert scale or a rating scale of some kind, that is instantly ordinal data. I'll go through why. There are some examples I've got. So one difference between nominal and ordinal is that ordinal is rankable data, whereas nominal data, you can't rank them necessarily. The other thing here is some examples. So pain levels. If you ring up 111 or 999 because you're in some sort of pain, they are going to ask you on a scale of whatever, 1 to 10, or this one just here, no pain, mild, moderate, severe, excruciating. I can rank them in order. So excruciating is more painful than severe, which is more painful than moderate, than mild, than no pain. The other key thing here, which is critical, ordinal data has a starting point of some kind that you can't go below. You can't go below no pain. If I say on a scale of 1 to 10, how much in pain are you? You can't go below 1. I said the scale was 1 to 10. You can't be like -10. You can't do that. That's not within the realm. That's not within the parameters of the scale that I gave you. So ordinal data has a true 0. If I made you run 100 meters, I start at 0. You can't go below 0. And if I'm ordering you in terms of how quickly you ran, it's rankable data and it has a true 0. Now, you can argue time its interval. I'm going to go through that in a bit more detail. Some other examples here. We've got the explanation here. It's clearly ordered, but the step... Now, here's the other thing you need to know about ordinal data. The gaps between the values are not necessarily the same. So the space between no pain and mild pain is not necessarily the same between mild and moderate or severe. The gaps between them are unknown or unequal. That's super key, and I want to apply that to the next example. So Likert scales, right? Strongly disagree is not necessarily the gap between strongly disagree and disagree is not necessarily the same gap between disagree and neutral. It's different people's opinion, for example. When someone puts disagree, they might be, they might feel quite confident about that, and some people are like, well, I disagree slightly. So the gap between the values are unknown. Ordinal data generally has a true 0. Again, look at this one on the right-hand side, where it says agreement, strongly disagree. Newcastle the best football team in the Premier League. Now, as it happens, I strongly agree with that because they're who I support. But I can't be like, no, I super strongly disagree, or super agree. That's not an option. So your answers can only exist within the parameters of the scale that I give you. Another example, never, rarely, sometimes, often, always. This is rankable data. I can rank this data. It has a true 0, as in like you can't go below. So ordinal data, again, I'll say it again just finally, it more or less has a true 0 that you can't go below. It is rankable data, so I can order them. And the gaps between the answers, the values, are not necessarily equal. That's pretty much what I've got here. So the characteristics, ordered, unequal intervals, and it generally has a true zero that you cannot go below. For example, on a scale of 1 to 10, you cannot go below 1, you cannot go above 10. Now, ordinal data, AQA love to go for ordinal data. Interval data is probably the hardest one. The thing you want to think about is thermometers. Time can also be interval as well. A thermometer, temperature does not have a true zero. Now you get physics students sometimes be like, oh yes, but minus 243 is the coldest temperature ever. I don't care. That's the coldest temperature that we know about. It could go lower beyond our human understanding. So sock it. Put a sock in it. But temperature doesn't have a true zero, right? We have 0 degrees, but you can go below that. Shoe size, IQ is a good example. So I've got. Let's go a bit further. Interval is the harder one. It takes things a step further. Yes, it has ordered categories. I don't want you to pay too much attention to that. The key bit here is that between the categories there are equal intervals. The gap between 20 degrees and 30 is the same as 30 to 40. It's not a case of opinion. They are set intervals, hence the reason why it's called interval data. They are set intervals. And it has no true zero. So I've got some examples just here. Temperature is the classic one. Is the classic one. The gap between 20 and 30 is the same between 5 and 15. In this case, 10 degrees. 0 doesn't mean no temperature. It doesn't mean 0. It doesn't mean the starting point. You can go below that into negative. Another one which I've never thought about actually is years. The year 0 isn't when time started. You can go before that. BC. 1 BC. Mary got pregnant. Well, sort of 0.75 BC. So again, the difference between 1990 and 2000 is 10 years, just like 1800 and 1810. So the gaps between the values are actually the same. You've also got, and I'd never thought about this, IQ. IQ is another one. IQ doesn't have a 0. You can't get 0 IQ points. Unless you're dead, but why would you be measuring that? You cannot get 0 IQ. I think the lowest I've ever seen is like 67, and that was someone with like severe learning difficulties. But that's probably almost as low as you can go, but you may be able to go lower. So I've got a couple of examples here. The main reason why you need to know this is because you need to be able to pick this out. Now this is a STEM. This is a STEM research methods, I should say, paper 2. You are very likely at some point in your psychology career, whether you're not picking psychology going forward, you are very likely going to have to pick out what the level of measurement is. Ordinal, nominal, interval. It is a brilliant piece of advice. What is being measured? What is being measured? That's what you need to go to. What is being measured? In this case, don't need to know the STEM here. One of the questions asked the students to rate how well rested they felt on a scale from 1 to 10 after the previous night's sleep. That's what's being measured. Now, is it nominal? No. They're not after categories here. They're not saying, are you this, right? It does appear to be ordinal. 1 to 10. That has a true 0. You can't go outside of those parameters. The gaps between 1 and 2 are not necessarily the same as 4 to 5 because it's opinionated data. It's unequal intervals. And you can rank them. I can literally rank them. 10 being brilliant sleep, 1 being awful sleep. I can literally rank and order how well rested they feel. So in this case, when it later goes on to ask, what's the level of measurement, you would say ordinal data. Similarly, we've got another one here, which is a bit harder, I think. What's being measured? Well, in this case, 2 things are being measured because it's a correlation. And when you have a correlation, 2 things generally are measured, called covariables. The map reading score and the driver rating. Both of these are subjective. Both of them are, well, this one here is 0 to 20. That one there is 0 to 10. They both have a 0, a true 0. They're both ordinal data. So my advice would be able to pick this out. That is levels of measurement. I think that's pretty much everything you're going to need to know. As always, hope it's useful. Peace out.